Are you able to see the slides?
No, sir.
No?
No, screen is not visible.
1 minute, 1 minute. I think they are not presented. I think now?
Yes, sir.
Yeah, yeah.
Yes.
Yeah. I think I've covered the optical fiber benefits in the last class. I mentioned, few benefits of optical fiber optics, which includes higher carrying capacity, less signal degradation, uh, then a long lifespan, and also right light signal, okay, interference. Then coming to the limitations, we have understood low power, fragility, and distance coverage. These are all some of the things which we have discussed in the last class. Let us continue in today's class, right? Multiplexing. When I'm talking about multiplexing, our focus is on wavelength division multiplexing and dense wavelength division multiplexing. Let us understand first what is multiplexing is, right? I think all of you are very familiar with multiplexing. It's a method by which multiple analog or digital signals are combined into one signal over a shared medium. The aim is to share a resource basically. The multiplex signal is transmitted over a communication channel such as a cable, and you can receive the data from a different data bit rate while combining your signals with one another. Having said that, right, multiplexer broadly classified into two types. One is analog multiplexing, the another one is digital multiplexing, right, where analog multiplexing further divided into two types, that is frequency division multiplexing and wavelength division multiplexing. Whereas your digital multiplexing, you know, right, is further classified into two types, that is synchronous time division multiplexing and asynchronous time division multiplexing, that is derived from time division multiplexing. Yeah, this is the simple pictorial representation to talk about multiplexing. Look at the top, right? You have, there will be an n channel, right, bit data which is coming in, right, which combines all the signals together, and right, the data is going to be transmitted over a single transmission medium here. Okay, it is nothing but there will be an many to one. Yeah, then when we talk about your, wavelength division multiplexing, here we focus more on there will be an light signals rather than there will be an right, other data bit signals. Okay, let us understand first there will be an frequency division multiplexing, right? It's an analog technique basically. In FDM, signals generated by each sending device modulate different carrier frequencies. I think you can notice that from the below diagram as well. Carrier frequencies are separated by enough bandwidth to accommodate the modulated signals. Right? I think you can right, able to transmit your data with different frequency, right, channel. You can assume here, right, f1 maybe with channel 1, f2 maybe channel 2, channel 3. It goes on like that. Okay, it's not there'll be only one range of frequency here. And as usual, right, as and when you receive at the receiving end, and when you're transmitting with the different channels, in order to send your data signals, right, at the receiving side, you need to have, there is a demultiplexer, and that's going to be categorized into different modulated signals to reach to the destination point. Yeah, this is the another scenario wherein you can notice that, right, how the data signals are going to be modulated with a very particular frequency range. Maybe at the top you have, there is an F1, and in the middle you have, there is an F2, F3. It goes on, with n number of channels, and all of them are combined together, and these things are going to be right now transmitted using a common transmission media, right? This is at the source side, and similarly you have to look at the receiving side as well. When it comes to the time division multiplexing, rather than talking about the Leben frequency, we talk about the Leben time division slots, and wherein, right, your data are going to be transmitted with respect to the time slots. Yeah, that's what is the message here. It's a method of transmitting and receiving independent signal over a common signal path by means of a synchronized switches at each end of the transmission line, so that each signal appears on a line only fraction of time in an alternating pattern. It's a method of putting multiple data streams in a single signal by separating the signal into many segments, each having a very short duration. Each individual data stream is reassembled at the receiving end based on the timing. So, what I'm trying to reiterate is how your time division multiplexing is right now different from the Leben frequency division multiplexing. Yeah, in order to understand there will be a better way, I think this particular pictorial representation indicates that, right, your digital signals carrying, your digital data from various sources are carried in a repetitive frames. I think you can notice the repetitive frames here. Each frame consists of a set of time slots. That is what is the key point in case of a time division multiplexing. Unless if that particular time slot is not going to be used, right, there may be a wastage of that particular time, and it may not be utilized properly. Yeah, each source is assigned one or more time slots per frame. Yeah, this is the another illustration to talk about this in time division multiplexing. I think you can observe it. The source end, you have a different data frames, that is an starting from AA to there is an DD, right, which are combining together, okay, which goes in a different data frames, starting from A, B, C, D. And again, that's same thing is going to be repeated. There's an A, B, C, D on, even if you have something else, okay, that's going to be added to the next data frame. Then at the demultiplexing side, right, each your data is going to be divided into according to the frames which you want to be sent to the destination. Yeah, having said some of the facts about frequency division multiplexing and time division multiplexing, you must also aware of it, right, how these two techniques differ with one another, right. To mention about these two, we have certain points here. I think you can start with the definition. You can also indicate some diagram, right, to showcase FDM and TDM. Apart from that, you can mention right now some more points like this. Look at the FDM, the signals which are to be multiplexed are added in the time domain, but they occupy different slots in the frequency domain. Okay, that's what I mentioned already. In case of TDM, the signals which are to be multiplexed can occupy the entire bandwidth in the time domain, right? That's the thing. Then FDM is usually preferred for analog signals, whereas your TDM is preferred for the digital signals. Synchronization is not required in case of FDM, whereas in TDM it is required. The FDM requires a complex circuitry at transmission and receiving side. A TDM circuitry is not very complex basically. Then FDM suffers from the problem of crosstalk due to imperfect basic filtering issues. Right. In TDM, the problem of crosstalk is not severe. Okay. Due to bandwidth fading in the transmission medium, all the FDM channels are affected. Due to fading, only a few transmission division multiplexing channels may be affected. And lastly, due to slow narrowband fading take place in the transmission channel may be affected in FDM. Due to slow narrowband fading, all the TDM channels may get wiped out also. Okay, I think we can go through these points apart from the pictorial representation of FDM and TDM. Yeah, the whole idea is, before going in detail about wavelength division multiplexing, you should have thorough knowledge about multiplexing. What is multiplexing, right? What are the different types of multiplexing techniques are available, how FDM, TDM differs with one another. Okay, then we need to follow, right, what is wavelength division multiplexing is. Yeah, in wavelength division multiplexing, right, passive or active devices are needed to combine, distribute, isolate, and amplify optical power at a different wavelengths. Right here, the focus is on optical signals. Yeah, this technology uses a multiple wavelengths to transmit information over a single fiber. First, WDM networks use just two wavelengths. One is 1310 nm, that is a nanometer, and the another one is 1550 nanometer. Optical transport networking is a next generation industry standard protocol that provides an efficient and globally accepted way to multiplex different services onto optical light parts, because in a global situation, everybody switching over from Ethernet technology to there will be an fiber optic technology, right? More and more migration happening from Ethernet technology to there will be an optical fiber technology. You get to know there will be many more things relating to these types of there will be multiplexing. Yeah, wavelength division multiplexing has a long been technology of choice for transporting large amounts of data between sites. It increases bandwidth by allowing a different data streams to be sent simultaneously over a single optical fiber network. Yeah, you can also categorize your wavelength division multiplexing into two types. One you can call that's an coarse wavelength division multiplexing, right? That is CWDM, and dense wavelength division multiplexing, DWDM. Yeah, the ODU, that's an optical data unit, is a basic payload that is electronically groomed and switched within an OTN network. OTN is optical, network. The OTU overhead adds bytes to provide optical section layer, PM, alarm indication, and the GCCO data communications. There will be a channel in case of there will be a wavelength division multiplexing. There will be a video also relating to that. I'm going to play you that a bit later, right? Yeah, this is the simple illustration to talk about wavelength division multiplexing. It looks like similar to your TDM and FDM, but here, your fiber optic communication wavelength division multiplexing, which multiplexes multiple optical carrier signals okay, on a single optical fiber by using a different colors of lasers to carry a different signals. That is what is you can notice on the right hand part of your diagram, okay, which accepts multiple right now optical carrier signals, combining them, and sending across. There will be an common right transmission medium. Yeah, this is the another right scenario to talk about. There is a wavelength division multiplexing similar to the previous one, right? We have number of transponders, right? That is TP1, TP2, so on to the will be an TP, right? For here you can have the will be an n number of transponders here from a different links, right? Which combines together using there is a multiplexing technique, okay, and then your optical signals are going to be transmitted, right, with optical fiber, and at the receiving side those things are going to be demultiplexed and distributed to the exact destination. Yeah, if you look at right all these signals, here what happens, right? All of them are going to be combined together. See here, that's an L1 plus L2 plus L3, right? Which are going to be distributed further at the other gain, right? At the bottom again, you can also have there will be the another view of how your wave division multiplexing is going to be used for transmitting your data signals. See here, an analog multiplexing technique to combine optical signals. That's one point. Multiple beams of light at different frequency, right? Then carried by optical fiber, okay, a channel again. It's a form of, there is an FDM, frequency division multiplexing again. Each color of light, carries a separate data channel. Okay, then commercial systems of 160 channels of 10 gigabits per second now available. So in the sense, right, user can always think about, right, their services accordingly. They can select right what is the requirement, then design and deploy such things at the source and the destination side. Yeah, again, some more complex type of wavelength division multiplexing technique. Okay, I think you can easily notice that, right, how your signals are going to be represented at the transmitting, source side as well as at the receiving side as well. Okay, yeah, you can write any one diagram and you can showcase, right, whichever you feel this is going to become a good enough for you, basically. Yeah, having said that, we have to understand some of the benefits of WDM. Okay, right, easier to reconfigure your WDM. That's one point. So then optical components are similar and more reliable. Okay, it provides there'll be an higher bandwidth. So that is the reason we go ahead with there'll be an optical fibers. Basically, this could be the best approach as it is simple to implement it. Right, it is similar to there is a multiplexing technique. So since you have there will be the basic knowledge of multiplexing, it is very easy to deploy and do the things as per your need, basically. And you can also provide high security with the help of this, because you can prevent data loss using right, by adopting there will be an optical fibers. Having said the advantages of WDM, we should also aware of it some of the disadvantages of WDM. Okay, signals cannot be very close. That's the one point. A light wave carrying WDM are limited to 2-point circuit. Okay, even though I said you can go for different channels. Okay, we are say that that's going to become a 2-point circuit basically. Scalability is concerned as a OLT, optical line termination has to have there will be a transmitter array with one transmitter for each ONU, optical network unit, because unless until you cannot extend like Ethernet technology there, you have a port and you can add up and scale up your network, but it's not that easy in case of your fiber optics. Adding a new own optical network unit could be a problem unless transmitters were provisioned in advance. Each ONU must have the wavelength specific laser. This is the very crucial point which you have to note in case of WDM. Cost of system increases with addition of optical components. Okay, right? You have to pay for it accordingly. Then inefficiency in bandwidth utilization, difficulty in wavelength tuning, then difficulty in cascaded topology as well. Okay, I think you have there'll be pros as well as there'll be cons. You have to decide, right? What is your application, right? Do you need there'll be an Ethernet technology or fiber optics technology? If I have it, how can I scale up my network? Okay, or how better I can utilize fiber optics technology for my usage or company usage, right? You need to think and go ahead accordingly. Yeah, do you have any questions from anybody? Hello? Do you have any questions?
No, sir.
No.
No, sir.
Yeah, I'll go ahead with DWDM now, right? 1 minute. I'll switch off my video. Coming to the next topic, that is dense wavelength division multiplexing, right? It's a fiber optic transmission technique that employs light wavelengths to transmit data parallel by bit or serial by a character. Okay, that is what is your DWDM is. Fiber with a great capacity of a bandwidth for long haul backbone data transmission uses basically WDM, which is a short for dense wavelength division multiplexing. You can call there's a DWDM in a short basically. It is one of the dominant technology used to utilize the application of fiber cable. It's a group of wavelengths and transmitted over a single core fiber. That is the whole concept of there is a multiplexing, irrespective of types of multiplexing technique, whether it may be FDM, TDM, WDM, or maybe DWDM. We could divide the fiber cores to multiple channels, and each channel with wavelengths to carry fiber optic data signal from site A to site B. Currently WDM system could carry 40G, 100G, 400G data in a single core. The capacity will increase in the future also. Okay, that means you can have there will be a different data speed, right? When you use there will be a DWDM technique. Yeah, I've already told you it's a fiber optic transmission technique. It involves the process of multiplexing many different wavelength signals onto a single fiber. Each fiber has a set of parallel optical channels, and each one uses slightly different light wavelengths. This is the key point you're supposed to note with respect to DWDM. It is a technology that puts together multiplexes data signals from different sources so that they can share a single optical fiber pair while maintaining a complete separation of the data streams. Yeah, you can observe it, right? What happens in case of DWDM, similar to the previous one itself, you have right transmitting and receiving sides, right, from left and right side, wherein you have transmit ends at both the sides, wherein you look at multiplexer and demultiplexer, and in between you have, there will be an right what do you call, there will be an filter amplifiers to generate your signals in case if it is I mean the signal strength is not good enough, you can regenerate those things. That is possible. Yeah, you can a dense wavelength division multiplexing system transmit digital signals from a specified number of transmitters to a like a number of receivers. The transponders match the wavelength and signal levels of the transmitters to that of WDM system. Having said that, you need to understand some of the applications of DWDM. Okay, right, meant for long distance communication operators that use either point-to-point or ring topologies. It could be used for building or expanding the relay networks. Okay, you have to bit careful while expanding it. You know that the limitation of the fiber optics as well. Then network wholesalers can lease can lease capacity rather than there'll be an entire fibers itself. Okay, because the cost will be very high. You need to think about to what extent we have to buy or to take a lease. As a result of that, you can easily reduce the cost as well. Yeah, the transparency of WDM systems to various bit rates and there will be protocols. Okay, utilize the existing thin buffer infrastructure. Then DWDM improves signal transmission as well. See, it is not a question of DWDM itself, right? The moment you go ahead with fiber optics, certainly, right, your transmission quality is going to be improved drastically. Yeah, this is the simple illustration or to the deployment at the industry, how exactly your fiber optic cables are going to be fixed with different rack switches. I think these are all belongs to the WDM and DWDM cables, right? You can easily notice, and also you have there'll be a caption on each one. I think you can easily read some of the cables, right? Caption there is an F19, F16, like that. It all belongs to the fiber optic cables, basically. Yeah, this is the application, right, or the deployment of your fiber optics. How these fiber optic cables are going to be connected with one another, right, in a circuitry diagram. I think data in or different channels. Okay, with wavelength signals, lambda 1, lambda 2, lambda 3, lambda 4, which are combining, right, comes to multiplexer. That's a 4-channel DWDM, basically, that is, right, where all of them are combined together, which gives you right, lambda 1 plus lambda 2 plus lambda 3 plus lambda 4. You can use the distance of 100 kilometer fiber, or even you can use it more also. In case if it is the distance is going to become more and more, obviously you can regenerate those signals. You can think about always amplifiers or repeaters, okay, in between, right? So again, when it comes to the other end of your DWDM demultiplexer, again those things are going to be distributed further with the same wavelength ratios of lambda 1, lambda 2, lambda 3 and lambda 4. In turn, it reaches to the destination. So the whole idea is, right, we need to understand how exactly WDM and DWDM are going to be used, and the data communication happens from site A to site B, or it may be any channel from one channel to another channel as well. Having said, right, the applications, you need to think about benefits of WDM, right? Coming to that, it's a less fiber cores to transmit and receive. There is a high capacity data. That is holds good for both. It may be WDM or maybe DWDM. A single core fiber cable would divide it into multiple channels instead of using there'll be 12 fiber core. Okay, that's what I mentioned earlier also. Easy network expansion, especially for limited fiber resource. No need extra fiber, but add wavelength. Low cost for expansion because no need to replace many components such as optical amplifiers. Can move to STM64 when economics is going to be improved. I mean, we are trying to reiterate that how DWDM is going to be more useful compared to WDM, okay, without having extra resources. The DWDM systems capable of longer span lengths, TDM approach using STM64 is more costly and more susceptible to chromatic and polarization mode dispersion. Okay. Yeah, coming to the limitations, that is in shortcomings of WDM, no cost effective for low channels. Low channel recommend there isn't CWDM. CWDM is coarse wavelength division multiplexing. It is nothing but WDM itself. You can just say that. Then complicated transmitters and there'll be receivers. Okay, that is what is the issue here. Wideband channel, you can say that capax and hopex. That's an I. So these kinds of channels may be required. The frequency domain involved in the network design and management increases the difficulty for implementation. Okay, that is the issue in case of DWDM. Having said, WDM and DWDM, right? If at all you want to summarize these two kinds of, there is a multiplexing technique. Okay, this technology is going to improve, your data transmission, speed, irrespective of your applications. Basically, the transmission efficiency will improve, and the DWD system will be more cost effective. Especially many Chinese vendors are able to provide DWDM turnkey solutions for the severe provider, internet company, data center, and so on. It is not only there is a Chinese company probably, right? You think any global companies which they want to improve the better speed and there'll be the quality. Everyone look for there'll be in fiber optics altogether, and they adopt there'll be in WDM and DWDM techniques. Yeah. Ultimately, we need to follow some of the differences between these two techniques, right? One is CWDM. CWDM, as I mentioned, it's a WDM itself. That's a coarse wavelength division multiplexing. I'm just abbreviating that. WDM system having less than 8 active wavelengths per optical fiber. Yeah. On the other hand, it's a dense wavelength division multiplexing. WDM system having more than 8 active wavelengths per optical fiber. Okay, it is less than 8, it is more than 8. Yeah, characteristics by defined by wavelengths, defined by there'll be the frequencies. Yeah, capacity is lower. Okay, obviously dense, it is an higher. Cost is low, it is an high, because you are trying to have that be more and more number of active wavelengths, right? Certainly the cost is going to become higher. Distance is, it covers there'll be in short range, and it covers there'll be in long range communication. Frequencies uses wide range frequencies, uses narrow range frequencies. Wavelength spacing, it is going to become more here. Less ends can pack 40 plus channels compared to CWDM in the same frequency range. Yeah, amplification, light signal is not amplified here. So here can be amplified it, okay. Drift is, wavelength drift is possible. Precision lasers are needed to keep a channels on the target. Then spectrum utilization, right, in WDM, breaks the spectrum into big chunks, right. It dies the spectrum into small pieces, okay. No active wavelengths per fiber, fewer than 8, that's a more than 8. So this particular point is repeated again, right? I think these are also the points which you need to be remembered, right, with respect to WDM and DWDM, along with right the pictorial illustration about these two technologies with respect to fiber optics. Yeah, I mean, we have certain points relating to technical specifications of these two technologies, right? Which talks about laser transmitter types. It's an uncooled DFB. A cooled DFB external modulation is used here. Spacing wavelength is 2,500 gigahertz. Around there will be 20 nanometer here. Here it is an 100 gigahertz with 0.8 nanometer. Wavelength fiber is 8 to 16. You can use it with the different channels like OE, SC, L bands. Okay. Here it is an 40 to 80. You can have C and there will be L bands here. Capacity of each wavelength is up to 2.5 gigabits per second. It is an 10 gigabits per second. Total capacity is 20 to 40 Gbps. And here it is an 100 to 1000 Gbps. Fiber technology is thin film, right? And whereas in dense WDM, it is a thin film, right? Or AWG or Bragg grating. Okay, we have different technologies right now. It uses different technologies for its construction basically. Yeah, transmission distances up to 70 kilometers. That's what we said. Maybe shorter distances, and this is for a larger distances. It may be 900 kilometers. Right, overall cost is low, and it's going to become medium. I mean, compared to your Ethernet technology, the cost of fiber optics is relatively high, but you can provide a better quality by using your fiber optics technology. I think we have some more points. I think I've already covered up these points by referring to the previous two slides. You can just go through these particular slide as well. Yeah, this is what is regarding fiber optics data communication channels relating to WDM and DWDM. If you have any questions, you can ask me here. Right. Otherwise, I'm going to share this video for a while. Okay, just a minute. Yeah.
When you think of accounting and finance, what comes to mind? Don't worry, this is not my course. I have something just a little more special planned for you.
In this video, I'm sharing a few quick tips for troubleshooting fiber optic connections on Cisco switches. On my desk here, I have two older model Cisco 2960 switches with the SFP ports, and they're connected by a strand of multi-mode fiber. None of the tips that I have to share here are really highly complex, but it was knowledge that I had to acquire while troubleshooting outages, so it was very hard-earned. So all I want to do is kind of share this out on the internet so that it will maybe save another network admin some headache whenever they have to troubleshoot one of these issues. The first thing that I want to share really isn't a command or something you can run. It's just a general piece of advice for working with fiber. Whenever you're bringing up a new link, I find that it's best to clean the connectors on the LIU side as well as on the fiber patch cord that you're plugging in. Even if it's brand new fiber fresh out of the bag, it can still sometimes come just dirty enough to cause either the link to not come up or to come up but to have interface errors. As for what to clean the fiber with, we've had pretty good luck with these Fuji Curl one-click cleaners. These have a little piece of thread inside so that whenever you put them on the end of the fiber connectors and click them down, the end rotates as it pulls new thread through. And these actually do a pretty good job of cleaning the tips. And a little known side bonus is that having some of these around will actually make you really popular at parties.
Save your wrist. No more twist.
One more tip that I want to share is that it's really helpful if you can get your hands on a digital fiber scope. You can use these to actually inspect the ends of the fiber and take some of the guesswork out of determining if they're dirty or not. I'm sure that there's more than one vendor who makes these, but one that I've used and have had a good experience with is made by AFL. I think these run about $1,300 new, so it's definitely something you'd want to try to have your company pay for. And you can use this with the full-blown OTDR kit, which is the very expensive option, or you can just purchase the USB fiber scope and then connect it to a laptop running Windows and run the application inside of there. And this also comes with a wireless option where you install the app on your phone and use that screen to inspect the fiber. And this basically works exactly like what's shown in the picture. You insert the fiber into the end of the fiber scope, and the image is blown up and displayed on your screen so that you can see if the tip is clean or not. I'll put a link in the comments to a video from another channel that goes more in depth on inspecting the tips of fiber using the digital fiber scope. The last thing I want to share are some helpful commands that you can run on switches to troubleshoot fiber. So I'm logged into my switch here, and the first command I want to share is the show interfaces command. You can see on the front of the switches here that I'm using gig 0/2 for their fiber interfaces. So I'm just going to add GI 0/2 to the command and then hit enter. And this command has a lot of output, but I find that the most helpful counters are the input arrows, CRC, and frame. All of these counters should ideally always stay 0, and if the numbers are increasing, it can indicate a problem at the physical layer. So most likely either a piece of fiber that's dirty or poorly terminated, or an SFP that is dirty or failing. The second command I want to share is the show interface transceiver command. So it's exactly the same as the show interfaces command, except for we add transceiver at the end and then hit enter. Now this command will only have output if your module supports a feature what's called digital optical monitoring. For whatever reason, this feature is not supported on all part numbers of fiber optic modules, which is kind of annoying. So you just have to make sure that the part numbers that you're buying support digital optical monitoring. If you're buying Cisco branded modules, they have a compatibility matrix that shows which modules support this feature and which do not. I'll leave a link to that in the description. Now as for the output of this command, it gives you the temperature, voltage, optical transmit power, and optical receive power. The output I use the most is the optical receive power, since this is measuring how much signal is actually getting through from the other side of the connection. And since it's measuring loss, it's represented using negative values. And you want this number to be as low as possible, with less loss being close to 0 and really high loss being close to -40. Whenever I'm troubleshooting a fiber connection or bringing a new one online, I always like to try to check these numbers on both switches. So on switch 1 here, you can see it's -5.6. Now if I go to switch 2 and say the exact same command, show interfaces, gig 0/2 transceiver, you can see that this switch is actually also receiving at -5.6. You can actually view the thresholds that the switch considers acceptable levels for these numbers if you just add detail to the end of the command and then hit enter. So there's a little bit more output to this command. If we go down to our optical receive power levels here, again you see it's -5.6 dBm. But now the switch gives us the acceptable thresholds over to the right here. We can see that the switch will be unhappy if the connection comes in at 0.0 because it's too high, whereas the switch starts to become unhappy if the signal is too weak at -17.0 dBm. And if the signal drops even lower to -21 dBm, then it becomes even more unhappy. So if it's a -5.6, it's still within that acceptable range. So that's it for this video. I just wanted to share these couple tips for troubleshooting fiber with Cisco switches. Hit the like button if this was helpful, and thanks for viewing.
Yeah. Hello. Hello.
Yes, sir.
Yeah. Right. I played that video to understand how fiber optics, right, technology is going to be used, more predominantly in industries for your data transfer. Especially there will be an the network dominant industries like Cisco. Not only Cisco, right? Name nowadays any company, they try to use these kinds of technology for the data communication. And also you want to troubleshoot something, what you can do it is you can go to a particular component, a prompt, maybe let us say you understood from the played video that you want to troubleshoot at switch 1 or switch 2, you can write a command at the prompt, that is so show interfaces, right? You will get to know, right, all the interfaces which you have used at that particular, site. And then, if anything is missing or if you are not configured anything out of it, you need to be configured it properly. So the same thing you need to be right, follow it at the other end as well. That means, let us say switch 1 and switch 2, right, are communicating with one another. Then you have to be check it out those things. Maybe relating to right your other network resources, maybe your routers as well. Okay, so you can also use, there is an iOS commands to troubleshoot right your network, as in when you establish your network at wherever you are. Maybe you can also check those things using your simulation tools, or you may do it in a right physical verification as well if you are looking into such responsibilities basically. Yeah, do you have any questions? You can ask me. Otherwise, we'll go ahead with the next right chapter, that is on unit 2 today. I'm going to start. So with this, right, I covered there will be in unit 1 completely. Starting from there will be in right packet switching networks to there will be in dense wavelength division multiplexing. Do you have any questions? You can ask me. Hello.
Sir.
No questions.
sir.
Yeah.
So far, no
Yes,
questions,
we
sir.
will go ahead with the next right now presentation. That is broadband ISDN architecture and protocols. I'm going to close this. I'm going to share. There will be the unit 2 right slide PPTs for you. Okay, wait for a moment. I'm going to close this. Hello. Hello.
Hello, sir. Yes, sir.
Able to see the
Yes, sir.
slides now? Hello.
No, sir.
No, sir.
1 minute.
No, sir. No,
Wait,
sir.
wait. I'm sharing it, loading it. Just yeah. Now, yes. Yeah.
Yes, sir.
Yes, sir.
Yeah. Fine. Let us go ahead with right broadband ISDN architecture and protocols. Okay, ISDN is integrated service digital network. Yeah, that is the first point I mentioned in this particular slide. Yeah, BISDN is nothing but broadband ISDN. Okay, it's an extension of ISDN in terms of capabilities. I mean, not only as the narrow band capability of ISDN, but also the broadband capability. I mean, it all varies based on the bandwidth utilization of your right network resources basically. It's a set of CC, ITT or ITU standards for digital transmission over ordinary telephone, copper, wire, as well as over other media. I mean, all ISDN standards were introduced by the ITU, International, that's a telecommunication unit basically. Yeah, it is the integration of both analog or voice data together with digital data over the same network, right? I mean, earlier we were talking about only data communication, but Subsequently, we have moved on to your digital data, voice data combined together. Okay, wherein you are trying to use data communication from site A to the remaining site B. That's what is we are talking about multimedia data communication as well. Okay, which is an amalgamation of four different kinds of, there will be the data, which includes image as well as audio, video, and a text. Okay. Yeah, based on the transmission and switching capabilities, the ISDNs are currently categorized into two types. One is narrowband ISDN, the another one is a broadband ISDN. Okay. As I mentioned already, narrowband ISDN is based on 64 kbps bit stream that are combined into higher capacity trunks using time division multiplexing. Okay, and the speed is very low in case of there is a narrowband. So that is why the name itself is a narrowband basically. Yeah, that is in terms of kbps. Yeah, and if you combine all these things together and using there is an multiplexing technique, and you want to transmit over a single communication channel, okay, that's a medium. You cannot have the same kind of transmission medium over there, because if you combine all of them together and you have, there will be the same kind of a transmission medium, then the congestion is going to occur. You need to ensure that the transmission medium which you choose must be very higher speed. Maybe if it is a kbps channels, obviously your transmission medium speed should be in terms of there is an mbps, or let us say if you have there is an gbps, also no problem. Okay, or gigabits per second channel is also no problem. Hence there won't be any issues. That's where you look at narrowband ISDN at one side, and you have there'll be the broadband ISDN on the other side. Okay, for the communication purpose. Hence there won't be any issues. If you have there is a narrowband at both the sides, obviously there is an issue. Yeah, the narrowband ISDN, however, cannot support the requirements of several types of data services, especially those needed for multimedia applications. That's what I said, correct? Because in case of multimedia, if you use your audio, video, and image, and if you stick on to narrowband ISDN itself, then certainly it is very difficult to do a communication between two ends. That's one thing, and there won't be any clarity in it. That's second thing, and there will be data loss also. Okay, and you require there will be more time also. Okay, lot many limitations if you stick on to that way narrowband ISDN techniques. Hence they have switched over to there will be a broadband ISDN technique. Yeah, having said those things, you have to understood what is BISDN is. It's a standard for transmitting voice data and video at the same time over a fiber optic cable. It uses a set of international telecommunication union standards and services designed to provide an integrated digital network for audio, video, and data transmission. That's the whole stuff is relating to multimedia communication basically. Yeah, the narrowband integrated service digital network is called the NISDN. This can be understood as a telecommunication that carries voice information in a narrow band of frequencies, right? The narrowband ISDN is implemented to carry voice data which uses lesser bandwidth on a limited number of frequencies. I think if you read all these points, you can easily distinguish how your ISDN or NISDN is different from broadband ISDN, that is BISDN. Yeah, it's an extension of an ISDN, only in terms of the name, everything is different, including protocol, architecture, transmission, and switching technology. Look, when we are talking about the implementation of these technologies, always you have to understand these key points, terminologies. Okay, what kind of protocols this particular technology uses? How is the architecture, of your broadband ISDN technology? Okay, how the transmission is going to happen it, okay, between two ends, and what is the switching technology it uses basically. Okay, once you followed these key points, then you can easily write your answers irrespective of the questions, whatever you get it. Yeah, these technologies designed to exploit the advances in technology. Okay, it provides for integration of wide range of communications facilities and the support of universal communications with the following characteristics. Okay, which includes 3 worldwide exchange between any 2 subscribers in any medium. Then 3 retrieval and sharing of information from multiple sources in multiple media. Then 3 distribution of wide variety of materials to home or office on demand. In the sense that, we are trying to convey that where exactly this particular technology is going to be used. Okay, and also overall the subscribers of this particular technology relating to marketability. Yeah, then yes, a broadband ISDN is a circuit switched service, but it uses there is an ATM to move your data. Okay, then backwardly compatible with ISDN. ISDN is, you know it now. Your BSDNs services offered with these ranges basically. One is it does full duplex channel at the data transfer speed of 155.2 Mbps. That's one thing, and also you have another data range speed. It is 622.08 Mbps. Then a symmetrical service with 2 simplex channels. One is an upstream with 155.2 Mbps. Downstream is 622.08 Mbps. Certainly, you may have some doubts here. Let us say when we have Ethernet technology and fiber optic technology, which supports a very high rate data transfer, why you want to use broadband ISDN here? So can I ask this question to you now? Will you able to answer it? Hello? Hello? Yeah.
Yes, sir.
Yeah. What is your answer for this? Have you understood my question now first?
Hello. No, sir. Once again, you can
See,
tell.
I mentioned that, look at this right now. BSDN services offered with 155.2 Mbps, another with
Okay, sir.
622.08 Mbps. There are some audio issues probably at your end.
Yes, sir. No, sir. Actually, mine from my side is nothing, sir. I think
Some,
it is.
some issues probably. Okay, no problem. But when we have, hello,
Yes, sir.
Yes, sir.
yeah, hello.
Yes, sir. You are audible, sir.
I am audible, but some right now. Okay, I'll leave that question. I'll move on to the next topic. One minute. Yeah, my slide is visible. Hello.
Yes, sir. Yes, sir.
Yes, sir.
Okay. was talking about, the speed rate of your ISDN is 155.2 Mbps and 622.08 Mbps, and also we have mentioned upstream speed as well as downstream speed. Okay, maybe 155.2 Mbps and 622.08 Mbps. However, there will be an advanced technologies like Ethernet technology and fiber optics, which supports a very high data speed range in terms of gigabit per second. But still, we stick on to broadband ISDN technology. Why? That is what is my question is. Are you able to,
Maybe because of their its characteristics, sir.
Yeah. Hello.
Like
Yes.
because of its a wide range of integration.
Exactly.
Integration
Correct.
of wide range.
Yeah, you have wide range of services. That's one point, and which requires there will be an right, connection oriented services basically. Correct. So when it comes to
Yes, sir.
connection oriented circuit, you cannot have there will be a very high end data speed like what you look for at fiber channel and your Ethernet technology. Okay. Yeah, I'll move on to the next topic of second unit again. That is broadband ISDN services. We are categorizing your broadband ISDN services into two types basically. One is interactive services, okay, where the interactive services are categorized into conversational services, messaging services, and retrieval services. And distributed services, where you have no user control of presentation, okay, and user controlled presentations. I think all of us, we are trying to use all these services in our day-to-day routine jobs basically, but we never are going to identify whether it is going to become belongs to interactive or there will be a distribute service. Some of our services are interactive, some of our services are there will be a distributive basically. We'll try to go in detail about broadband ISDN services. Okay. Yeah, it is based on a change from a metal cable to fiber optical cable at all levels of telecommunications. Right. I think once again you have its classification, right? And we are trying to reiterate once again what is interactive services are here. Okay. These services require two-way exchanges between either two subscribers or between a subscriber and a service provider. I think most of the time we are trying to do some kind of charting basically. So it's an interactive service. Let us say you chart something, then you get a response accordingly. You start doing some kind of with the other end. Unless that's not going to happen, you're not going to continue your communication basically. Okay, looks like a very simple application, but we can achieve. There will be a lot of real-time responses using your interactive services. It may be applicable to various scenarios. Maybe let us say I'm just doing my class. I will ask you a question, right? So then you're going to respond for it. Unless you're not going to respond it, I'm not going to continue. Okay, I'm not going to get any response. What I will do, I may put it in a chat box stating, saying that, are you listening to me? Okay, are you ready? Okay, if I get a reply, then I'm going to start. Otherwise, I'm not going to start. correct? So some kind of data movement or a communication happens further and further with a very specific message, communication between two ends. Okay, that's what you have different types the below. One is conversational real-time exchanges such as telephone calls. You can write a lot of examples, real-time examples for all these things. Okay, let us say you speak to your friend. If you are not getting any response from the other end, are you going to speak? No, it's not possible. Okay? Messaging, store and forward exchanges such as there'll be a voicemail. So that is another kind of interactive service you provide. Retrieval, retrieve information from a central office. Right, even that is possible, because when it goes to, there will be an indirect kind of data communication most of the time. Retrieval, interactive services is going to happen, because it is not possible to present all the time by yourself, during your interactions. Sometimes you have to be store it, and then you have to be retrieve it from there'll be the particular office. Yeah, if you look at the pyramid structure of your broadband service, the two types of services could represent it like this. Okay, that's what you can just see. At the base level, you have distributed distribution services, because it is not under your control most of the time. Okay, some of them may be there, but not all the services. It all depends upon your applications. That's why all distribution services are at the base side. Okay, and as and when you move on to the tip of your pyramid, certainly you are at the interactive mode, right? You get a response and then you are moving on. Okay, so hence it could be represented in this particular form basically. Yeah, then having said the pyramid structure, let us understand what is distributive services, right? It's a unidirectional services sent from a provider to subscribers or a broadcast to the user. Okay, wherein we have without user control, user choice is limited to whether or not to receive the service at all. Sometimes it may be limited, or not to receive the service at all. That's one thing. Then the second one is with user control. Allow the user a choice of times during which to receive them. Right? That is another kind of control. You have it relating to distribute service. So say, for example, let us say you want to watch a movie from a centralized server, which is available in the website. Okay, wherein you want to view a very specific movie, based on your choice. Okay, that's a user control basically. But sometimes what is happening when the broadcast, which is going to happen with a very specific time, let us say at 3:30 today, this is the movie which is going to be broadcasted to everyone. Everyone should view the same thing. You don't have any control over it. So what I mean is, when it comes to the distributed services, you have a control and you don't have a control for something. It all depends upon your applications and services. You get it from the other end of service provider basically. Okay, that is what we need to think about it. I think you can write a lot of differences, examples relating to interactive services and distributive services, maybe relating to number of applications, whatever we do in our day-to-day basis. Yeah, having said that, some more details on interactive services and distribution services. Okay, interactive services, two-way exchange of information, between two subscribers or between a subscriber and a service provider. Distribution services, primarily one-way transfer of information from service provider to ISDN subscribers. So even when we ask you any questions relating to these kinds of services in a quiz, right, we may give some applications. We may ask you to identify whether it belongs to interactive service or a distribution service, so that you can easily identify. Okay, because services are many basically. Yeah, having said that, we have some more services relating to distribution services with user presentation control. Distribute information from a central source to a large number of users, right? Information is provided as a sequence of information entities, that is in frames, with cyclical repetition manner. User has the ability of individual access to the cyclical distributed information and can control start and order of presentation. Okay, so that is the example of cable text. So we are trying to talk about user presentation control. Let us say when you are watching a TV, right? So you, even though you have so many channels to view simultaneously, but it is not possible to view all of them at a time. So whichever the channel you would like to view it, okay, that information, you can gather it, and you can start viewing that particular details. Okay, it's a user presentation control basically. Yeah, having said that, user control presentation, let us understand without user presentation control as well, are referred also as a broadcast services. BBC is a broadcast user presentation without user presentation control basically. Provide a continuous flow of information which is distributed from a central source to an unlimited number of unauthorized receivers connected to the network. Right, who are connected to the network, they are supposed to get the same information during that particular instance of a time. That is broadcasted to all. You don't have any control over it basically, right? User can access the flow of information but has no control over it. You can just think about various applications relating to it and talk about it in detail. Example, high definition television. Yeah, the best example is there is a movies probably, correct, no? Which you get it quite frequently in your broadcast medium. Yeah, we have certain examples to both basically, right? That is interactive services and distributive services, right? With respect to conversational services, you can talk about video telephony, video conferencing, data transfer, and so on. Messaging, you can write voicemail, data mail, and video mail. Retrieval is video retrieval from an online library. Okay. And on the other hand, we have distributed services without user control, a commercial TV. Okay, and with user control, educational broadcasting, tele advertising, and pay TV ads, whatever it's. So you can think over and talk about various examples related to BISDN services here. Yeah, having said that, you can also look for various applications because all these services required your internet based infrastructure, and the moment you talk about infrastructure based applications, always you need to think about high speed data networks, high speed networks, high speed infrastructure, high speed devices with you. Unless you don't have these things, it is very difficult to have the better connectivity and quality of service between two ends. Hence you need to think about high-speed networks, right, in a big sense. Yeah, to mention few applications here, you have enhanced phone services, then customer premise equipment devices usage, then high-speed data transfers wherever it is applicable, irrespective of your applications. Critically, right, in case of medical applications or defense applications, right, or maybe where your data is going to become more and more critical. Okay, so there you need to think about your right high speed networks. Okay, otherwise it is very difficult to have there will be better results during your interactions. Telemessaging, right, applications, then video text applications, teleconferencing applications, telecontrol, telepooling applications, telefinancing applications, online services applications, then right remote video surveillance applications. Okay, so these are all some of the applications we need to think about it. Let me ask you right now, okay, can you tell me first one belongs to which type of BISDN service? Is it an interactive or is it a distributive? Hello.
Sir, interactive
Yes. Interactive.
interactive phone service.
Interactive, sir.
Yes. Second one, customer premise equipment.
Distributive, sir.
Customer premise equipment, you distributive. High speed data transfers.
Data
Distributive, sir.
transfer
Distributive. That is, it is not under your control because why some audio issue. I think maybe connectivity issue because my topic of discussion is high speed network, right?
Yes, sir.
Unless we are unable to connect ourselves with specific right data speed, then it is very difficult. Yeah, high speed data transfer is distributive. I think you understood why is it correct, no?
Yes, sir.
Yes, sir.
Telemessaging.
Interactive messaging is interactive.
Yeah,
Interactive.
messaging is what is interactive. Video text.
Interactive.
Teleconference.
Sir.
Teleconferencing.
Fencing. Interactive. only, sir.
Interactive because unless you are not coming right now virtually with one another, it is not possible to do any kind of communication, right? It's an interactive. Telecontrol and telepolling interactive. Telefinancing, all tele applications comes under there will be an interactive. Online services,
Distributive, sir.
distributive. It need not be instantaneously you have to do it. You see, you just do something, later you are going to get it accordingly, correct? Remote video surveillance. Remote video surveillance.
Distributive, sir.
Distributive, because right, you are storing it all of them, correct? No, you can
Sir.
have it in a repository. Later, you can use it based on your requirement, correct? That's possible. Okay, so that is what is you need to think about it. Once the set of services are given to you, you want to be identified, right? It belongs to what? Interactive or there is a distributive. How these things are going to be varied with one another. You need to follow it very clearly. Okay. Yeah. Let us understand how the ISDN networks looks like. I'm just going to view this. Okay. Going to play this video probably, correct? 1 minute. Yeah. This is the right now ISDN network. Maybe you can call it the BISDN network. This is okay. you have right LAN network on one side, call it as an A, and the other side also we have there's a LAN network. Let us assume that two sides A and B. Then you may have there's an ISDN bridge, okay, and even sometimes you can have it a router also after connecting all of them into a switch. So nowadays, you can replace your hub with a switch basically, correct? And ISDN bridge you can replace with ISDN routers on both the sides. What I'm talking about right now. Okay, then you may be connecting your ISDN routers, that's a bridge from side A to side B via there is a fiber optic cables once again. So that is how you can design and deploy your ISDN network for your data communications, right? Yeah, this is the another network design and deployment, or construction of your ISDN networks, right? Just see here, you have a telephone line which is connected to an ISDN. Your laptop is connected, or even you can connect your cell phone. Name any devices, terminal, devices. All of them you can connect it to the right ISDN switches. Okay. Then you can have these kinds of data communication technology. Let us say that's what I said. Your broadband ISDN uses ATM connection oriented ATM networks for the data communication purpose. So then I look for that being a switched technology, or let us say your ISDN may be connected to your computer networks. Basically, there you need to think about a packet switching technology for your data communication purpose. Or let us say, as I mentioned earlier, it need not be switched on the LBN packet. I need to have some kind of lease lines for my connectivity. Certainly, I can go for a private LAN, okay, and I can able to communicate from there is an A to B. I mean, you have different options for you to establish your networks, right? As and when you want to communicate from A to B. It all depends upon the size of the network, right? Or the size of, the organization, right, where you are doing your, business basically. Let us say if it is, small, maybe, right, certainly you can have your private line and you can able to communicate it. And still, it is medium size, you can go ahead with the LBN switch, okay? Or if it is too large, then it may not be possible to have the LBN provide as well as the LBN switch. You need to go ahead with the LBN packet switching technology ultimately. I mean, you can have different technologies to design and deploy your ISDN network. I think you can able to write your own design relating to that probably. Yeah, some of the features of there is an ISDN, right? It uses a digital signal, uses existing telephone wiring. Charges are generally based on the duration of a call. I think you have come across of that, because that's the reason, your telephone call rate is very high compared to other data communication. Then alternative to using there's an lease lines, right? I mean, you have a different technology. Sometimes you can use the lease lines, or else think about alternative technology as well. Can transport many types of network traffic, which includes voice, data, video, text, and graphics, and so on. And next one is faster data transfer rate than there will be in modems. Okay, and faster call setup than there will be in modems. I mean, a lot of configurations you are trying to do it during these kinds of data communications. I mean, when we talk about ISDN digital network, you may do call pausing, call waiting, call dropping sometimes. You can retrieve a lot of details from your services. I think those who are working with right, receiving end or maybe the sending end also, right, you can able to notice it, provided if you are working in a mobile or telecommunication industries regarding these kinds of LBN services. Many more services are going to be added as and when you work with different applications. Okay. I think I'm covered up many things on the LBN broadband ISDN services. I think I'll stop the stage today. I'm going to continue in the next class. There will be an ISDN components in detail, okay, and many more things. If you have any questions, you can ask me. Right. Otherwise, right. I'll stop. My class at this point of time. Do you have any questions?
No,
Hello? No questions? Yeah, 1 minute. I'm just going to share some of the. I think yeah, for every chapter I have added some right now video lectures as well. You can listen to those right now.
Integrated Services Digital Network, or ISDN, allows the digital transmission of voice and data over copper pair. It began in the early 1990s to provide circuit-switched connections for either voice or data in increments of 64 kilobits per second. This session will provide an overview of ISDN fundamentals with an emphasis on ISDN Primary Rate Interface, or PRI. Some basic definitions of ISDN fundamentals will first be provided. Then, the Layer 2 and Layer 3 signaling protocols Q921 and Q931 will be examined, followed by a sample call flow using Q931 messages. We will conclude with a section dedicated to troubleshooting tips. As previously stated, ISDN stands for Integrated Services Digital Network. With ISDN, voice and data are carried by bearer channels, also known as B channels, which occupy a bandwidth of 64 kilobits per second. A data channel, also known as a D channel, handles signaling at 64 kilobits per second.
Yeah, hello. Hello. Hello.
Yes, sir.
Yeah, I mean that particular slides talks about 1 minute. Yeah, it talks about the different interfaces we use with respect to an ISDN technology and its basics. I think I'm going to play this video tomorrow because I'm expecting good strength in the class to proceed further. Okay.
yes, sir.
And I think many of them are in the internship program, right? They need to study it through the slides as well. I'm going to share this video presentation, and also I'm going to share there will be the slides whatever I have presented to all of you. Okay. In the meantime, if you have any doubts, you can ask me any kind of there'll be any questions as well. Okay. I think sir is right now. Given there will be the topic for both of you to work on. Am I right?
Yes, sir. Given
Yes,
sir,
sir.
are doing it.
Yeah.
Yes.
And you should identify your internship and project topic separately, in the sense don't have the same topic for both. Okay, that keep it in mind and start working with your project as well as internship. Right?
Okay, sir.
Yeah. Any other questions you have it? Yeah.
No, sir.
Okay, fine. Then we'll stop the stage today. Right. We'll continue tomorrow. Right at 11. Fine.
Fine, sir. Yes, sir.
Yeah. Thank you. Bye.
Fine, sir.
Thank you, sir.
Thank you.
Thank you, sir. Thank you, sir.
Thank you.